model for the representative diagnosis of mental disorders in adults applying machine learning. Authors: Emanuel, Davila, Velasquez, Erick, Ramirez, Barja, and Lenis Wong. Introduction. In recent times, traditional psychological assessments using paper questionnaires have resulted in delays and potential calculation errors in the results. Besides, the diagnosis of mental health conditions in hospital relies on outdated technology, leading to delays in quality care and accurate diagnosis for mental disorders and common illnesses like anxiety and depression. Based on the gathered data, the proposition of developing an expert system for the representative diagnosis of mental disorders in adults using machine learning. This solution must be capable of rapidly and accurately analyzing various symptoms and complaints, reducing the risk of misdiagnosis caused by the vast amount of information managed during a patient's evaluation over time. Related works. One of the factors explored is predictability and memory suppression process. This study focuses on individuals with traumatic experiences and how they are significantly affected. The diagnostic system is based on the self-reporting questionnaire, which has been designed by the WHO, the World Health Organization, and is publicly accessible. The SRQ focuses on assessment and identification of depressive anxious disorder, psychotic disorders, compulsive disorders, and alcoholism. The SRQ questionnaire consists of 28 items, with the first 18 referring to depressive anxious symptoms, items 19 to 22 relating to psychotic disorders, item 23 to compulsive disorders, and item 24 to 28 addressing alcohol consumption problems. Data understanding. Regarding the sample to be used for data collection, the participants are defined as Peruvian adults who are currently studying or working. The collected information allows for identifying the mental state of each person. The survey conducted aims to obtain conscious-based responses for study purposes. Table 1 shows that 31 questions grouped by variables and questions type. It comprises 34 multiple choice and open text questions, including those from the SRQ questionnaire. In this table, as you can see, we have some questions about the anxiety variables. For example, do you frequently have headaches? Do you have a poor appetite? Do you have trouble sleeping? Those are some questions in the questionnaire about the anxiety variables. Data preparation. Data cleaning. In this phase, after obtaining responses for the web questionnaire, data cleaning and structure updates were performed, followed by a variable encoding. The cleaning process involved selecting the necessary variables to be used in model training, and then the restructured dataset was encoded in a correctional manner to serve as input for modeling. Modeling and training. In this stage, the dataset is imported into the Google Scholar tool for data processing and model training. The dataset used is the one resulting from the web questionnaire. At this point, ML algorithms are applied to survey data to predict the type of present disorder in individuals. The proposed model will utilize information for anxiety, psychotic, and alcoholism variables to identify the behavioral patterns based on the type of disorder. In addition, the predictive algorithms that have had the best performance in related studies, decision tree, random forest, and support vector machines. Figure 1 shows that Python code used to train the RF model. In the first step, dimensions, variables, number of estimations, and learning rate initialized. The effectiveness of models is confirmed using the test data from the records. The algorithms that yield the best outcomes in terms of accurate and inaccurate predictions for disorder identification are determined by computing metrics using confusion matrices. The ROC curve for each algorithm is illustrated in Figure 2. The RF algorithm outperforms the others with an AUC of 0.96 as shown in Figure 2C. Results and discussion. Table 2 displays the count of accurate and inaccurate outcomes for each algorithm, specifically during a test data iteration for disorder 2. The model that utilized the RF algorithm recorded the highest count of accurate predictions at 342. This was followed by the RR and VT algorithm, which made 275 and 321 correct predictions respectively. Figure 4 offers a comparison of the ROC curves generated by the three algorithms. The RF algorithm stands out with the highest IUC value of all 96. While all algorithms are deemed effective in identifying positive values, it's clear that RR and VT algorithms tend to produce a higher number of false positive predictions. Figure 5 shows the comparison of the model's results on a scale from 0 to 1 with training and test data. Regarding metric precision, some algorithms achieved a result higher than 95% in mental health prediction by disorder, except for the RR and DT. The RF algorithm showed the best precision, meaning the proportion of correct prediction for a total validation dataset. Regarding the AUC score, an indicator for model performance, DT didn't perform very well for the data set. Unlike the others, RR and approximately 86% failing the test, while RF had a value of 0.96, indicating good results for the model. Conclusions and future forms. In this research, a test evaluation model was proposed for the prediction of mental disorders. Compared to ML algorithms, data collected from the SIQ questionnaire was used and the algorithms RR, DT, and RF were trained. The dataset was constructed based on the SIQ questionnaire, which consists of questions aimed at identifying problems in mental health. The 28 questions are all closed-ended and are grouped by variables related to disorders. The results showed that the RF algorithm achieved the best performance as classified 26%, with a considerably adequate accuracy 93%. And in some iterations, precision ranging from 0.90 to 0.96. RF proved to be a suitable model to meet the minimum prediction rate agreed upon by the team members. As future work is recommended to employ machine learning techniques for the productivity and as complained the healthcare sector. Aim on the advantage, it allows streamlining processes, benefiting both patients and professionals, reducing manual tasks, and increasing productivity. It's suggested to optimize the use of proposed technology in research and achieve greater benefits for the society. It's included that there are various applications of these technologies in health, and it's hoped that this contribution will encourage further research in these fields. Thanks.